IC formula is E by R minus E power minus C by RC. So in this case, so this is a VC is 9 millisecond by R to E power. So this is a negative value minus C by R whole C. So you substitute here. So that will be the VC 9 millisecond. So this is the minus 5.44. 5.44 divided by the resistance value is that we already calculated 10 kilo ohm. 10 into 10 power 3. E power minus C by R whole C. So R whole C is 2 into 10 power minus 3. And then you get for the current IC. So current IC we calculate. So that will be this formula is minus 0.054 into 10 power minus 3. So IC you can calculate it minus 0.054. E power minus C divided by 2 into 10 power minus 3 ampere. So those are the calculation. So the difference between previous program and this program is previous programs are voltage only the symbol. The voltage source, resistor and capacitor are in series. So you directly substitute the resistance value. But this one is the more complicated because there are 3 resistors. So only you can solve by this way is you have to find the Darwin equivalent resistance. So to calculate the Darwin equivalent resistance, so resistor across the capacitor, you see the circuit. So to find the Darwin equivalent, you have to K the source. The voltage source is the short circuit. Short circuit there you find the equivalent resistance. So then you can find the RDH. And also the voltage is as EDH, Darwin equivalent voltage. So you have to find the voltage across the distance, the Darwin there. So this is EDH. So those EDH and RDH have to be substituted. Okay, the last portion is a capacitor connected in the series and the parallel connection. So capacitor in the series and parallel. So capacitor are to be connected in a series parallel. So that when you connect the capacitor, you have to tie it. So for instance, this is a voltage source here, capacitor C1, capacitor C2, and capacitor C3. They are connected in the parallel. So in this case, you can calculate CD. CD is C1 plus C2 plus C3. So this is called a parallel connection. And now what is the series? CD means that this is the voltage source here, voltage source E. So capacitor C1, C2, and C3 are connected in series. And for series connection, you have to calculate that 1 by CD is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is for the series and the parallel connection of the capacitor. So this is the capacitor connected in series connection. Because of this one, you have to find the total capacitance. In this case, you have to combine in the parallel. 1 by CD is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So we substitute. This is a 1 by 200 microfarad plus 1 by 50 plus 1 by 10. So by solving this one, you got the thing is a 0.125. So 1 by CD. So CD is equal to 1 by 0.125. So you got this 8 microfarad. So by this way, you can calculate that to the capacitance by this way. Okay, for the CD connection, the charge is the same. The same charge. Same charge. Because the CD connections are all current and same, therefore that we can assume that the charge are also the same. So CD connections are the same charge. Same charge. So same charge means that Q3 is equal to Q1 equal to Q2 equal to Q3. So Q2 is equal to Q1 equal to Q2 equal to Q3. So Q2 you can calculate. Q2 formula is the C total into E total. So this is for the total charge. So the charge to the capacitance and the total voltage can be calculated by this formula. Q total is CD multiply E. So then you have to calculate Q2. We already know that C total. The Q total is the C total is 8 into 10 power minus 6, and the E is the 64. So by solving this one, we call it in 480 into the 10 power minus 6. 10 power minus 6 pull out. Okay, so now you can calculate the V1. V1 is Q total is equal to Q1 divided by C1. So then we get 480 into 10 power minus 6 divided by C1 is already calculated at 200 into 10 power minus 6. By solving this one, you got the same with the 2y44. And the B2, so Q2 divided by C2. So Q2 is the same, 480 into 10 power minus 6 divided by C2 is 50 into 10 power minus 6. So by solving this one, you got the gain at 9.64. And B3, so Q3 by C3. So Q3 is 480 into 10 power minus 6 divided by C3. So C3 we already calculated 10 into 10 power minus 6. So you got the 48 volt. So then you got the E. By solving this, you add everything, you call it E is always 60 volt. So this is the way that we calculate the coolant charge across the capacitor, and also calculate the energy stored in capacitor. Energy stored in capacitor we use half into C into V square. Energy stored in capacitor half into CV square. The unit will be the joule. So capacitor body. So in this problem, you also calculate the energy stored for the energy stored in capacitor C1. So this is a half into C1 into V square. So then we can calculate. So the C1 half multiply C1 is capital C1 is 200 microfarad. 200 into 10 power minus 6 multiply voltage V1. V1 is 2.44 square. Right? Just way that you can calculate for the energy stored. So then you can calculate it. Then we just 2.4 square multiply 100 to 576 into 10 power minus 6. 576 into 10 power minus 6. So 0.576 millijoule. So this is the capacitor, the energy stored in the capacitor. Okay, today I talk about the transient circuit. Transient circuit means that we charge the capacitor